Welcome to tutorial 14, the never-ending level of tutorials that you will get in this actual class, but this time we're transitioning now into classes and objects. Now, what you have to dig back into your knowledge here is the fact that back in the day you learned about structures. So structures as a way that you can define a new type that's built up of other data types inside of it. Now, what classes give you now is the case where now I can have more than just having the data associated with it. I can have a set of operations that will then also change that data. Because a lot of times before this, the linked list, all that stuff that we've been doing is you'll make your new structure to have some of the data, but then you'll have a function that takes in some kind of data type of that structure, the head pointer or something like that. Well, classes now start getting us into what's called the world of object-oriented programming, a different style of design compared to functional programming, where you can now have your data and the actions that will affect that data all bundled together. So now think of it being separately being a structure and the functions. You now think of it being, well, I define a class and then I got all these objects that I can make from it that then have the data internally that's controlled access to it, and then you access it through calling the actual methods. And so now we're going to be going back to that dot operator and building up everything from here. So for this tutorial, we'll be using the tutorial 14 code that's in the tutorial directory. So if you don't have that yet, pause the video, go get that from the library and copy everything over. When you do get that, you should see everything you see here. You should see the bank.cpp.h, datecpp.h, and .cpp, your make files, your time, and tutorial 14. And so this has all the code for this tutorial and stuff that you need to start making. You have your usual handy dandy make file that we've always had before this, so that it'll compile and run and clear the screen. You got your clearing. Boom. So you can compile it and then run it. And if you run it before we do any of the code, you should see similar to stuff to what we see here for right now. Now the first thing here for question 1 is we want to consider having the actual date class. Now here in the write-up, it's very vague, but I've provided some actual examples for you so you can see examples of creating actual classes. And this is where we're getting back now to having the .h files and then the .cpp files. So in this case, for the date class, and this is good convention for code here, is that you're keeping each class in its own separate kind of file. Is nice to do is that you'll see the date.h, so you can open that up, date.h. Got data. It's date with an E, not data. Got H, and it's your start of the normal .h as we've seen before. But what you're going to see different here now is we're not just defining the actual methods here. We now have a new definition to make your actual class. So I'll just make this window full screen for right now so you can see the code easier. So before, when you're making a structure, you would have had the keyword structure at the top. Now we're making what's called a class, which is a definition, which ties the object. This is a definition saying the blueprint of how to make an object of type date. And it'll define the actual data that you'll see internally inside of it and any actual operations. And so here you think of this as your prototypes, that we're defining it here. We have all the prototypes for all of your methods, and then the .cpp will actually be defining the actual code for these methods themselves. So when you start here, you'll see you have a class, the thing here. Now what you'll see here for being the public colon and everything else in private colon is these are new things that you can object-oriented that are called access modifiers, being what can be accessed inside or outside of the object, falling under what's called encapsulation. So right now, anything that's being public means if I make something of type data, I can call and access these methods and this data. Anything that's declared as private, I cannot access it unless I am writing stuff inside the class. And this is to help with design and control of access to who has access to what actual data. And so within the actual public, you could have some actual data could be accessed here, but usually it's just methods is a good design. Private, you can also have other methods, maybe if they're just used for helper methods that don't need to be called by anyone else. And then you have your actual data and things you're working with. These, the case for the date class, is a full date class. These static const things that you're seeing here can explain more in the future, but this is just to have constants that are only related to the actual date that are set, like the names and everything else. So you don't need to fully understand everything from here, but knowing that we have the methods, we know .h, we have the definition of everything, so your prototypes. And then if you open up date.cpp, you'll see where you actually go through and defining everything. So initializing our constants. Now what's going to be different here is when you're doing your prototypes now is you don't just have the return type of the name of the function. Well, this function is inside of that actual class, and you have to tell the compiler that case. So I'm including the .h for the original definition at the top, but now to say that we're defining the prototype for the set method that was in the .h is we say the class name that it's in. So you're always going the return type, the class name this method is supposed to actually be in. So data, then you go colon, and then you put the actual rest of the definition. And so this lets the compiler know is, oh, this set method is for the definition for the date class. And then you have access to your code. The nice thing here is then you have access to everything you actually need. So we won't be going much further on the internals from these. You'll get more practice in actual class, but I wanted to provide you with a fully functioning date class that represents what you'd have for a proper actual objects class. So this one thing is just that the structure represents everything around representing a date and printing it, setting values of the day, month, and year, incrementing and doing some work here. So it's fully functional. You can look through, play around this, try to understand this, how it figures out everything else, how it figures out an algorithm. Right here using Zeller's algorithm that based upon the month, day, and year, you can figure out what the day of week should actually be. Right here, what is the end of the month for all of it, and all that fun things, determining if this date falls within a leap year, everything else. So I'll shrink this back down. And so now this first question, what we're doing is you're not writing as much on the internal. That'll be more practice for a later question. But here, what we're trying to do is go through words of instantiating a date object, then setting the date to your birthday, right here. This says in 2019, doesn't matter from here, whatever, setting stuff here. So increment the date until it's the first Sunday following your birthday and output this. So this is really more just like back when you learned about structures is making a structure and working with it. And so this is presuming like you have this case here where you already have the actual date class. How do I start doing work with it? So I'm going to open up the date.h so it's easy to see the actual prototypes. And what you guys want to do is open up then tut14.cpp, which has your main and runs everything in here. And we want to go to question 1 function. So both of them are on here, and we just have question 1. Now the first step is when you want to say you want to instantiate an object just as a normal variable, right here is in C++, and we're not dynamically allocating it yet, is going to be similar to just doing a structure. Is that we want an object of the date class, called date here, so we use the type date, and just give it any other name we've used for any variable. And at this point in time, that means we have instantiated and we have it. And so just like the structures, it means it creates all the data, and then now we have all these methods that we can call within it. So this D object that we have down here, it's going to go through creating everything, and everything's data is going to have these constants in here, and it's going to have these ones at the bottom of day, month, and actual year. And then we'll have access to all these methods. Now the next thing is, well, this is D, and you know when you had structures and you were doing things like linked list, and you had your node, you'd have your current arrow or head arrow next access or head dot next access data inside. Well, this is going to be similar when we want to work with methods to do some of the actual work. So here it says, sets the date to your birthday from right here, and in here what you look for is you're trying to look for a method that will access and do some of the work. The actual fields themselves, so instance variables that are down here, are hidden. You can't access them. It has to go through an actual method, and this method here means, okay, I can call this function. Now to call any of the functions, we don't just go set and call it, we're saying d.set, which means, okay, it'll be the set method from the date class, and it's running this against specifically the data that's for object D. And so this will go and run that method, which sets it in here saying that it's the day, the month, and the year. So for right now, I've put this in as my birthday for right now. It's like things you never really want to know about the teacher who's been making these tutorials. My birthday is June 23rd, 1981. So I am 40 years, almost 41 at the time of recording this video in 2022. If you're following along here, I suggest change this to be your birthday so you can see all the output. So put in what is your date. So the date, put in the month being what month it is, so that like 1 would be January, and then 2 would be February, and so forth from here, and then what year you were. Now when we go next is here is, okay, well we want to then, I have it calling the print, so we go d.print, passing cout, right here. You see the print. And so what this means is that we're running the print function again from the actual date class, but specifically against the object D. That's where we're going d.print. So when you're seeing this, we're not just calling one function. It means, oh, it's going to take the data and use it that's inside of actual D when it's doing its work. So if I open up date.cpp, we can go up to the print method here, and we know, okay, when we're calling print, and we're calling it from an object of type D here, which is type date, it means, okay, here we see void, date : so this is the print method for the date class. It's going to go and access all of these, and you can see where it's doing some of the work, like here it's saying month, and you're like, okay, well, where's month coming from? That's that instance variables that are declared inside the actual class, the private, so it's doing some of its work. So here's that first step. A, instantiate the object, there you go. Set the actual date to the birthday. Here we're calling the method, passing it in to do work, so now we're passing this and setting it specifically for this object here. If we had a different date object, it wouldn't change that one. It's only this one here because we're saying, hey, call the set for this object that's with the name D. Next here is increment the date until it's the first Sunday of the following month, and so this is an actual just loop. So again, the increment method, as it's specified, you can see the documentation at the top up here, just means that it increments and adds 1 day to the current actual date and then moves it forwards. So what I'm doing is here is, okay, just go in here, increment the actual date, whatever we are, I print it actual out, and then I check what is the day of the week. So again, what I'm doing called get day of week, by going d.get a day of week, I am saying, okay, get the day of week, but call it against this object here, which will then use the data internally for that object. And in this case, 1 means Sunday, 2 means Monday, and so forth. So this will then keep incrementing and printing until we actually get to that actual Sunday. And I'm calling the print each time. And then we have outputting the actual date, so that's the print. So let's go and compile this, and I'll run it. You can see the output for the beginning one is we have the actual print coming up right here. So we have the D object that we've actually created. We have the set to June 23rd, 1981, and then I have the print. That's what you're seeing here. And the print method converts the proper day of the week, gets the month name and everything else, and formats it out nicely. And we're calling it specifically against the object D. Next, you can see then when it's going into the loop and we're doing, I'm saying increment, so we're changing what should add 1 day to it, and then I'm outputting it, the date. So you can see it started here. The original date I have felt that in June 23rd, 1981, when your teacher was born, here it was a Tuesday. And then I call increment, which adds 1 day. You can see then it goes to Wednesday, June 24th, then 25th, then 26th, 27th, and finally stops when we finally hit to the actual next Sunday that you're seeing here. But I'm going to make it even more clear that making another object. So if I make another one date, and I call this D2, I've now made a second date object that's separate, and I can start setting dates that are different from here. So I can go here, okay, D2 dot set to another date. I'll do today's current date while I'm recording this actual video. So it is the 3rd of February, of March, when I'm doing this, so 3rd of March, and so that is 3 for the actual month, 2022. And so again, what this says specifically, and now I'm calling this set method, but against the object D2. So this date will be set into this object, this date will be set into D. If I come down and do a second print, so D2, and I call the actual print, we go back to the main. Run this here. You can see the first date right here, June 23rd, 1981, and you can see where I call the print on the date object 2, which gets that specific data, and you can see, hey, March 3rd, 2022, and yes, today is an actual Thursday when I'm actually recording this actual video here. So you can see that's the important part when you're reading this to now know when I'm calling the function set, it's specifically doing it against the data that is saved inside of the D2 object versus this one here. So that's why it's important to have the data. And knowing when you're calling this, it's not a function, it's also this function that has all the data inside of that object and it has access to it to do the rest of its work. Okay. Now, part 2 is the thing you have to do for an actual hand-in for this, is that you have the time class. So we can open that up again in the time.h. And so this is similar to the date one. It's supposed to represent keeping time in the day, so hours, minutes, and actual seconds. You have your normal huge long documentation. You have the definition of the class again as well. You have its publicly accessible actual methods that you're working with right here, and these are all the prototypes where the actual code for the rest of it's in the CPP. And then we have the data that's hidden for access to this. I can explain more in the future for object-oriented actual design. So you have access. So every object that's creative type time will have this data in here, and then these are the methods that you can actually call and access off of that object itself. So what we're having to do here is that everything works. And so you can see, again, you got the time.h. We'll open up the time.cpp as well. And you can see once again in the .cpp, you do the time.h for each method that you want to define, like how we have set value. When you're saying you want to define the set value that's for the class called time, then you're going the return type, then time, : then set value, and doing the rest of the work. And so that's very key. Without this, it would just be a function that's called set value, whereas this is specifically the set value that's defined for an object that'll be of type time. And so you can see the set, you can see the increment. So this works the same as everything else, that this increments the seconds. So set just sets the data of hours, minutes, and seconds. Increment actually increments the seconds, and then based upon how many seconds, so every 60 seconds increments the minutes, every 60 minutes increments the hours, and every 24 hours wraps it around. So doing military time. It'll then do printing of the actual data from right here. It'll do comparisons of is equal. And now this is one nice thing is that you can now have the case of this actual function is that one object can take in another object from here. So we declared time. So this is taking in time other, and we're comparing that the current object against the other one to see if they're actually the same. Same thing for the less than, total seconds, getting hours, and even the difference in overall actual seconds that's in here that you'll see we'll be getting to shortly. Okay, so what we have to do for this one is a little challenge. So we're going to open up tutorial 14.cpp. And this is more a challenge, is just get used to calling methods from an actual object and working with two different objects from the same data type. And so we want to go to question 2 right here, and this is where it's going to be running through it, where I basically call the methods and we are completing the actual compare and print method that's just above this, that's blank right now, that basically takes two time objects and calls methods to compare each other from them. And so in question 2, when it runs it, I'm showing first instantiating two different objects, so time 1, time 2, setting two different time values from right here, and then calling the compare method, which will then do the work to compare them. So calling the method. So in here, and then you can see I'm changing the data that's in time 2 now with the set value, and then doing comparison again. And above here, you're getting exactly the output that you should be expecting for each of the prints. So you can confirm if you've got this right. If you don't get that same output, you've done something actually wrong. So the first idea here is that right now in the actual time class itself, I'll go to the .h for my bottom part of this. Is that we've got these methods in here for doing a little bit comparison of is equal and is less. Now the time class supplies these two methods, but it's not complete. So these correspond to equals equals and less to. Now what we want to do is make a few methods just to simulate the ideas of not equals to, less than or equal or greater than or that, which you can do all logically with these for stuff. What I want you guys to do is that we're going to go into the actual compare and print method right now, which by default right now just prints out some message and just calls a print. So it prints out the time for both of the actual time objects that were passed in. And we want to add things here is that if time 1 does not equal time 2, we want to output the message T1 not the same as T2. And all we have to do here is not adding new methods. We're only able to call the is equals and is less than, and using the logic ones. Now, this one's really easy for the first one, is that I want to call the is equals, but we're comparing time 1 compared to time 2. Now, to do that right now with just the methods that were provided, we'll start with an if, and then we go time 1 for the actual first object. And now I want to compare it to the other one. I can't just go equals like this yet. We can do that later on. It's called operator overloading and stuff like that if you want to do, but this won't do anything for the actual comparison because this is a more complex data type. It's like the structures when you try to compare them. So here instead is we want to call the method saying, hey, T1, we want to compare you to T2. So we go time1 dot right here, and then we want to use this method here, the is equals, and we're saying, hey, time1, we want you to call the method is equals and compare your data against the other object that we pass into you, time 2. So this means time 1, compare yourself to time 2. And this is supposed to return true if they're the same, false if they're actually not. So what we want here instead is that, okay, if I just go not in front here, is that when these are equal, this will return true, and then the not will make that false, and so we don't go into the actual if. But if this returns that time 1 does not equal time 2, this will return false. The not will turn that into true, and we will go into the if, so we get what we want. So if time 1 does not equal time 2, we go into the actual if. And then we want to output our message. So see out. I'll be lazy because I don't want to type the whole message. Boom. Okay, let's go and actually test this for right now before I go on. Oops, make. And we have the first one right here going through is time 1 and time 2, and we get the output. They're not the same, which you can see. It's not the same time, so we're good. This, when they are the same time, doesn't print that message out. And this coming down here, we also get, hey, yeah, it is not the same. So it's working good so far for these. So now next we need to go through and just do the similar thing. And so what we're doing is just using some logical expressions and calling and comparing the functions and doing it the similar way of that time 1 dot is equal and giving it another object to compare to. So we'll do the next one. Boom, boom. I am just going to copy this top one just because I don't want to type everything out, and then change the message as we expect. So when this one's supposed to work, we're getting this second message that's down here. Less equals. So now we've got to start calling the methods and filling this function so that we can deal with if time 1 is less than or equal to time 2. So we know so far we have time 1, and again, to do a lot of this work, we can see the functions we have access to, and we have the less than, and we have the equals to. So we can go to this A first, logical addition, if time 1 is less than time 2, passing in for that function. So telling time 1 to compare itself against actual time 2 to see if time 1 is less than time 2, because again, we're calling this function on the data that's in this object and passing time 2 in as an actual parameter. What we want to do is also if it's equals, then so if it's less than or the actual equal being the actual same, this time we'll do the equals. So if it's less than, right here, and I don't want to do less than and equals to because I won't care either if it's less than or if it's equal to. That's the same as doing less than or equal to. Okay. I'll keep doing the other ones and then we'll come back and actually test some of these. So copy that one again, go on to the actual next one. Copy the message. Here, and so this we're doing if T1 is greater than T2. So it means that they're not equal to. So one thing about this is that we just check things of A, if it's time 1, because we're not doing greater than or equal to, it's just greater. And so if we do here, I'll just code it first and then explain it. So first off, it's got to be not equal to it because it has to be greater than that. And so in that case, if it's not equal to it, right here, and it's not less than that, then time 2 has to be bigger. So in the case here, if time 1 is less than time 2, right here, it'll go the opposite because we're saying if time 1 is greater than. So if this is false, if time 1 is less than 2, this will return back true, which then this will be false, and we won't go into any of the rest of this statement. Now, if time 1 is not less than t2, which means it must logically be bigger, then this will go not, and this will give us true. Now, we have to equals, we're not doing greater than or equals to, so by going not time 1 dot equals, we're making sure as long as it's time 1 is not less than t2 and time 1 is not equal to t2, then the only logical thing you can have out of this, because if it's not equal and it's not less, it has to be greater than from right here. And then finally, we're just dealing with if it's greater than or equal to. So this is just going to be a variation of what you had above. We'll get our message set up right here. Okay, so this one here is, we still know, is it greater than or equal to? So we still know by going not less than, that makes it equal to. But now we want to do the case of, here, is it actually equals as well? So similar to being above, is that if it's equal, or if it's greater than, then output this actual message. So let's go now and start running this. So that does all 4 of these. Right here, so A, B said. If you missed some of that or I was typing too fast, I am just going to scroll up here in a second for the actual method itself so you can see the entire method. You can pause the video at this time so that you can actually copy out the same code that you're seeing here. So the top one of A, if it's not equals to, B, if it's less than or equal to, C, if it's greater than, right here, and the last one, if it's greater than or equals to. Okay. Now going question 2, we'll go and just verify that everything worked properly for output, knowing that we should be getting these messages when you did the comparisons of the actual data. So let's hope I got it right the first time. Okay, question 1 we got here. We should see T1 not the same as T2, T1 less than or equal to T2. Boom, we got that. That's perfect. The next output, we should be seeing T1 less than or equal to T2 and T1 greater than or equal to T2 after changing it. So you see here, so it's, you can see the next one here, T1 is less than or equal to T2, yep, and T1 greater than or equal to T2, okay, good. So that's the next one that we had right here for printing out the data. So you can see they match. So T1 is less than or equal to, so which is right, and T1 is greater than or equal to, which is right. So we're matching here. So the very last one, when we change the data, it should be printing 3 messages out to us, which we can validate here. We have T time 1, we have T time 2, so they're not the same. T1 is greater than T2, you can see that's true, and T1 is greater than or equal to T2, which is also true from right here. Okay, good. So that's everything for you. So again, if you missed copying that, I'll just make this big screen. Here's the entire method, and once again you can pause the video and make sure that you have everything from here. And this is part of what you need to hand in and make sure that this works. Now please don't stop the video right now because you're done the hand-in component. Please go on to the next part so you just get a little bit of practice. Now I've done these and coded it already, so I'm just going to talk about them just to make this video go a little bit quicker. But it says here is basically adding some new methods into the time class. So if you want to add new methods and new work to it, what are the steps you need to actually go through? So you can see this already coded and inspect this. So if we open up again the time.h, you can see where I make the prototypes first for each of these methods. I want these to be publicly accessible, so I make sure that where it's public : it's under here, and it's before anywhere where you hit the private. And you basically just define it like you would define every other prototype you've done, but making sure that it's defined within the brackets as a class to say that this will be a method for an object of type time. So you can see here, get hours returns the current value of time of the time hours. So this is what's called a getter method. I go look, well, this is what I'm going to be returning. This is of type int, so my get hours should be of type int. So defining here. Same thing, so get minute, minutes is of type int. We're good. Get seconds, seconds is of type int, so I'll do int right here. Next is saying the difference is I want to see returns the difference in seconds between two times. So it means between the current one that we have here and another object. And so we're defining here is, okay, this is the method that's going to be called to access and work against this data. And this is going to be the one what we're comparing against. So an object of that same type. Yeah. And then you have like a total second method here. So that's how you first do the prototypes for the methods in the .h. But then in the .cpp, again, remember, so you'll find this more closer to the bottom, coded right here, is you have the get hours, is now that you have defined in here, hey, this is defined inside of an actual class, so when you go to it, you'll use the same prototypes. You can see get in hours, but then you go time : : to say that this is the get hours that it has a prototype in the time class. And then you just do your normal work. And what's key about this is you can see you're wondering, again, where does hours come from? Is hours here is also defined in this class. So it means we're accessing for the current object, it's hours automatically. That's in the actual time class itself. So where those came from. So you can see the get minutes right there. You can see get seconds. And you can actually see the actual difference in seconds. So what I call here, this is the difference. So I'm calling the total seconds, which again, you can see, look here, there's no dot. Here's a special thing. If you see no dot, it means call a method that's in the same class. So you can see how it's defined here saying total seconds. So it means against the current object we're in, call the total seconds. Whereas right here we have time other. So it means other dot total seconds is, oh, call the total seconds but against the object other, which will have different data in here. And this gets the data back between the two of them. Boom. Okay, last is then to deal with specifying a whole new class from blank right here, and that's the bank account. And instead of me typing all of this out and making the video longer, again, I've already got this done. So you go Control X, Control F, bank account.h. So here is that you can have multiple classes defined in the same file when it comes to C++, but to make finding things easier, sometimes it's easier that you just name it. If I'm making a bank class, then I'm going to have a bank, like I'm going to have a bank account.h where I do the class and its prototypes, and a bank account.cpp to actually have the definitions of those prototypes and make it easier to find everything. And so your normal if and def, so it doesn't get returned. And I want to, again, make a new class called bank account. So I go class and then that actual name. The important part. Any of the methods I want to be public, I go public : and then have the methods defined afterwards. And you can see here where I want to have methods set balance, get balance, deposit, withdraw. And you must be able to do storing the balance as an actual double. So what this means is A, I make an instance variable, keeping it private, saying that this is balance, that all of these methods will have access to do their work again specifically. And here you don't want to have your temporary variables, just something that's only for a bank account, and balance makes sense for this, so that you have a balance for your actual account. And next from here is you define the rest of the actual methods. Now if you open up bankaccount.cpp, forgot the space. I mean underscore. For every method that's in here, once again in the .cpp file, you'll see you first include the .h file. You make every method in here and you include the class name. So again, we're making set balance that's in the bank account class. So bank account : and then taking in its parameters. And then when I go balance here, you can see set balance, and I'm just accessing balance. It means, okay, I'm accessing the balance for the specific current object. Doesn't mean there's only one balance. It means for every one that I instantiate, when I'm doing this, it's going to make individually work against that. So you can see these aren't perfectly coded methods. I just wanted something that would run. So getting the balance, doing a deposit, which literally doesn't do any error checking on the actual values, but just adds it to it if you're doing a deposit. Withdraw, just minuses it. No proper error handling, but just something that compiles for you. So I suggest if you guys want to play around with this more, is try to write it on your own again, but go and see like, hey, can you go to the tutorial 14 main and now instantiate an object of type bank account and set its balance and do a withdraw? Can you add in a print method that prints out the balance for this current actual account? And so then can you do a deposit and withdraw and do the print and see the balance and everything else, kind of statements like that. So other than that, make sure that you're understanding the syntax of how to read it, how to work with the actual objects and calling methods externally, how to at least define the stuff, and we'll deal with later on of how you start designing it. But we've been doing this now already for 35 minutes. Now, normally I go for 40 or 50, but I think I'll stop now, let you guys have your time to play around with this, and just make sure that you feel comfortable with it. As we get later into the semester, things go faster, and we're getting closer and closer to the actual exam time. It's better to make sure that you're not behind a material, and you're keeping up and asking questions earlier on. If nothing else, if you get behind, you're still awesome people. Stuff happens. From right here, and you just pick yourself up and keep going and try to do your best, and maybe if you don't learn it perfectly now, maybe you'll learn it perfectly later on in the next course or in the future. We got long lives ahead of all of us. And if nothing else, I'll end off with the usual, that I hope all of you are having, you're doing well or as well as you can. And never forget that you're awesome. And as always, if you think you're not awesome, you're wrong. I say I'm right, and you will always be awesome. Bye bye bye.